Hello, welcome back. For this lecture, we will continue our discussion about sorting algorithm, and we will discuss our second sorting algorithm about uh, selection sorting algorithm. So why we call it a selection sorting algorithm? Because in this algorithm, we are going to place an element at a time in its correct position. Okay, so we are going to select an element at a time in its correct position. And this algorithm is also an iterative algorithm. So similar to also use nested loop structure. Okay, and this time the outer loop keep track of the current position for the correct position that to be filled. That's the outer loop. And the inner loop is to find the best element. Okay, typically we either find the smallest or the largest element in the unsorted part. So this is a general idea about selection sort. So next, let's take a look at the example. Okay, so similar, we still use that example. Okay, so for selection sort, the idea is to find the best element to be filled one at a time. So the outer loop keep track of the best location. Okay, one at a time. So generally speaking, in our discussion, we will do small to so smallest item to largest item. Okay, we are going to do this kind of sorting. So then the first correct position to be filled is the first element. Okay, so basically first element. So in this list, we can clearly see it's supposed to be 18. Is it 18 supposed to be filled at the first location? So then this part is sorted. And then the remaining will be unsorted. So that's the outer loop. Outer loop first iteration. Okay, let's move to the next iteration. So 18 already sorted, so it looks for the next clear, next smallest item. Clearly, we can see it's 35, right? So then the remaining are going to be unsorted. So after the second iteration, the first two items are sorted. So you're going to keep doing this until the unsorted list has only one item. Then basically, no more find the smallest or largest is it item for single item. So then the loop ends. So sorting ends. Okay, so gradually, so the unsorted from assuming the size is n, is it from n to like 1? Okay, unsorted list. Okay, so then let's take a look at this example. Okay, so we identify this is the position that we are going to fill. So then we are going to look for the smallest item. Okay, in the remaining items. So it's from sub 0, this is from sub 1 to sub n minus 1, okay, to find the smallest. And we can clearly see 18 is the smallest. And then you compare with the item that at its location, is it? So clearly it's smaller than that one. So you do need to exchange these two, okay? So then 18, then 35, 69, 87, 50, 58, 70. So that's the end of the first iteration. So this one is sorted, and the remaining are unsorted. Okay, and then we're going to look for the next position that need to be filled. So clearly we can see this time it should be this item. So sub 1, that, and then the remaining, we need to find the smallest. The smallest is going to be 50. And then you compare it with that item. So it's already greater than, so no swap needed, no exchange needed. Okay, so then after the second iteration, it's 18, 35, 69, 87, 50, 59, 70. So this first two sorted. Okay, and then we are going to repeat the process again. So this is the position that we try to fill, then we try to find the smallest. And we can see 50 is the smallest in the unsorted list. So we are going to swap these two, okay? So then it becomes 18, 35, 50, 60, 87, and 69, 58, 70. Okay, so this time the first three sorted and the remaining are unsorted. So we keep doing this, okay, until the last, at the end of the outer loop, then your unsorted list will only have one item. Then that's the end of the sorting. Okay. Well, then that means all of the items are sorted. Okay. So this is how selection sort works. And so keep that in mind that for selection sort, the outer loop is to set the correct position. Okay, in our case, it starts from sub 0, then sub 1, sub 2, and you keep trying to fill that position with the right item. And how do you find the item? So in the unsorted sublist, you find either the smallest or the largest, it depends. You want sort in ascending order or the descending order. And then you can fill it, okay? You find one, then you compare, and then determine if the exchange needed, okay? So that's regarding selection sort. For the selection sort, in our textbook examples, we also have a method that implements selection sort using an array. Okay, so you can go ahead to read it. So that's the end about the discussion of selection sort. So we will come back at the next lecture for the next sorting algorithm.